It's time for some more mathematical methods. We are going to look at the formal method for division today in this one. We're not looking at long division, we're just looking at short division here. We're going to look at short division with no remainders. We're going to look at short division with remainders, and then we're going to look at how actually we can turn those remainders into a decimal. Okay, so let's get started then. We're going to start with 736 divided by 8. Now I'm going to use the short formal method for this. The short formal method is often informally referred to as bus stop, because this looks like a bus stop apparently. Now what I need to do here is I need to be really good at my 8 times table. Okay, and if I'm not really good at my 8 times table, I can do something about that. I can help myself out, and I can simply just write that down here. So that would be 8, 16, 24, 32, 40, 48, 56, 64, and 72. I'm not going to write 80 down because I don't need to get to my 10 times, because otherwise we'd kind of already be there. Okay, so if you're ever writing out a times table for a division, the maximum you'd ever need to go to is 9, and often you can stop before that if you use a bit of common sense about our maths with this. Now I'm going to come back up to my short formal method here. I'm going to see how many groups of 8 I can make from each of my numbers, and that's how this is going to work. So I'm looking at my first digit, which is my 7. Now in every other method we've been working from right to left. We've been looking at the least significant digits first, and then the most significant digits. When it comes to division, we need to work left to right. We start with the largest value, the highest value, the most significant digit that we have. Okay? So I'm going to start with my 700s. How many groups of 8 can I make from 700s? How many groups of 800 can I make from 700? Well, the answer to that is none, because I can't make any groups of 8 from 7. So I carry that over, and I just pop that up here in front of my 3. So my 3 now has become 73. Now what I can do is I can use my times tables, and I need to work out how many groups of 8 I can make from 73. And if I don't know that off the top of my head, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 groups of 8 gets me to 72. Now that's not 73, but it does mean that in 73 I can make 9 groups of 8. Now if I have 9 8s, I'm at 72, which means that between 9 groups of 8 and 73 I have 1 left over, because between 72 and 73 there's 1 left over, there's 1 remaining there. So that gets carried over into my next column here. And so instead of it being a 6, it's now a 16. So I'm looking at this and I'm thinking, how many groups of 8 can I make from 16? 1, 2. Which means that my answer for this calculation here is 92. Okay, fairly straightforward. We've done quite a lot of work with this across the whole of Key Stage 2. We should be quite secure with that. And remember, the key thing here is if you're really still a bit wobbly with tables, write them out, get them written down. My next one here, you'll notice I have the same calculation twice. That's because I'm going to show you how you calculate to find remainders, but also how you calculate here to find decimal answers. Okay, so same thing again. I'm going to pop my calculation into my short formal method for division, otherwise known as bus stop. Okay, I'm not going to write out my 4 times table here, because actually I'm a bit strong with that. I don't need to do that off the top of my head, so we're going to just work it through this way. Now I'm thinking about my first digit. Remember, we start with our largest, our most significant digit here. I'm thinking about this. How many groups of 4 can I make from 5? Well, I can make 1. There's 1 group of 4 in 5, but I have 1 left over. So that gets carried over into my next column. That turns my 1 here from being a 1 into being an 11. So I need to think to myself, okay, well, how many groups of 4 can I make from 11? And if I know my times table, I know we'll go 4, 8, 12. Now 12's too many, so I can make 2 groups of 4 from 11, but I have some leftovers. 2 groups of 4 is 8. So that's where I would be here. But I need to know what's left between 8 and 11. And that will give me a remainder of 3. So I carry that over into the next column, and now I have 37. I need to know how many groups of 4 now I can make from 37. And if I know my 4 times table, which we should, I know that 9 lots of 4, 9 times 4, 9 groups of 4, gives me 36. So in 37, there are 9 groups of 4, but there's 1 remaining, there's 1 left over. So I can put that down as R1, remainder 1. So that would give me 517 divided by 4 is 129, remainder 1. Now we're going to have a look at this exact same calculation, but this time instead of winding up with a remainder, I'm going to show you how you can turn that into a decimal answer. So, same setup. 517 divided by 4. Short formal method for division, bus stop. How many groups of 4 can I make from 5? 1, with 1 left over. How many groups of 4 can I make from 11? 2, with 3 left over. How many groups of 4 can I make from 37? 9, with 1 left over. So up until this point it's been exactly the same. But instead of popping my remainder 1 up here as I did before, what I'm going to do is I'm going to put a point 0 here. And I'm going to extend my bus stop slightly, my short formal method for division slightly. I'm going to put a decimal point up here. And instead of carrying my remainder up here as remainder 1, I'm going to carry it here next to my now point 0, which actually gives me a point here, 10. Now, I need to know how many groups of 4 I can make from this. So 4, 8, 12. I can't make 3, but I can make 2. But I still have some remainder. And I need to keep doing this until I run out of remainders. Sometimes that won't work for some numbers. But if it's a number like 4 or 8 or 2 or 5, we should be able to get down to a point where we lose all of our remainders. Okay, so here I carried my 1 over because I made 36 was 4 times 9. I had 1 left over, so I carried it here. I made 2 groups of 4 from this 10, but I have 2 left over. So what I'm going to do is not have a 0.2 remainder 2. I can't have a point and a remainder, that doesn't work. What I'm going to do is give myself another 0 and carry my remainder 2 over to here. Now what I've got is how many 4s can I make from 20? 4 times 5 is 20 exactly, with no leftovers, with no remainders, which means that my answer here is 129.25. Now the interesting thing with that is if I come back into this one here, this was my answer, 129. I had 1 left over. And what I could do is I could do that as a fraction actually. Instead of remainder 1, I could have 1 from my remainder and 4 from my divisor. So this answer here, 129 remainder 1, is actually 129 and a quarter because I had 1 left over and I was dividing by 4. Okay, so I can also put a remainder as a fraction. But we should also remember that 1 quarter is equivalent to 0.25, which is why that answer there is also 129.25.